Assalamu alaikum students. So our today's topic is factoring polynomials. Yesterday we did factoring polynomials using GCF, the greatest common factor, and today we are doing factoring using difference of squares. Now let's get a quick review of multiplying binomials. So if you have binomials with both the numbers same and just only positive and negative in between, you can see these two, 5x plus 1, 5x minus 1. They both have the same numbers, but only the difference of the sign. 2a plus 3b, 2a minus 3b. So what do you think the answer will end up with? Let's get started foiling it. First, you multiply the both first, then you multiply the both outer, then you multiply the inner, and then you multiply the last. It's called foiling. So let's multiply the two firsts. X times x gives me x squared, and O means outer, so x times 4 gives me negative 4x, and then the inner gives me plus 4x, and then the last for both the binomials gives me 16, negative 16. So when I simplify them, negative 4x and positive 4x gets cancelled, and I end up with x squared minus 16. If you look at the pattern, x squared, the final answer is x squared minus 16. If you look at the pattern, it just ends up with multiplying only the first x and x and 4. It gives you x squared 16, and plus and minus when multiply gives you a minus sign, right? So this ends up with a difference of two squares. These are the squared terms because x and x gives you x squared, and 4 and 4 gives you 16. Okay, 4 times 4 gives you 16. That's why they are called the difference of squares. It can only happen when we have the two binomials with the same number. First and first are same, the last and last are same, and they have the different sign, opposite sign, positive and negative. Okay, so let's FOIL them. First, 5x times 5x gives me 25x squared. Outers, the outer is this and the outer is this. 5x times negative 1 gives me negative 5x. Inners are these two. 1 times 5x gives me plus 5x. And the last, 1 times 1, positive 1 times negative 1 gives me negative 1. These two cancels out, so I end up with 25x squared minus 1. You see? So if you match it with 25x squared, you can get by multiplying 5x times 5x gives me 25x squared, and 1 times 1 gives me 1, plus and minus multiply gives me a negative sign. Okay, it can difference of squares can be done when we have different, they are opposite signs, okay, in sign. Now let's do this. First FOIL them, we check it, and then we'll figure out what the pattern is. First, 2a times 2a gives me 4a squared. When I'm multiplying the variables, I'm adding them, okay? So 1 plus 1 gives me 2. Outer, 2a times negative 3b gives me 6ab. Now inner, 3b times 2a gives me plus 6ab. And then the last 3b times 3b gives me minus 9b squared. When I simplify them, like terms, these two cancel out, and I end up with 4a squared minus 9b squared. So you see the pattern? If you have both the term numbers same in the binomial with just the plus and the minus of difference, then you can end up with this. This is called the factor of difference of squares. We use this rule. So we will use this rule. We are going to factor. We're going to do the backward opposite, this way. From this binomial, we end up with factored form. Okay. okay? So from here, we're ending up here. So what two numbers? This is a square, this is a square, and this is a different sign, okay? That's why they're called difference of two squares. Now, what is the rule? So the rule would be make two parentheses next to each other. The first one will be positive, the second one will be negative. And what times what gives you a square? Is a times a. And what times what gives you b square? Is b times b. This is the rule you are going to follow, inshallah. Okay? Factor the following difference of squares. Check your answers by foiling. Okay, so what is the process? Two parentheses. We are doing this backward thing, okay? From the difference of square, you are writing the factors. So plus minus, it could be either minus plus or plus minus, okay? It could be either way. A times a first check that they a perfect squares, both of these, and do they have minus sign in between? Then you can do that, otherwise not, okay? So a times a gives me a squared, and plus and minus makes it negative. 4 gives 2 times 2. So these are the factors you can check by foiling. Now first check them whether these two terms are squares, okay, perfect squares, and do they have difference, then you can do it, okay? So now let's do this. Can be get by 9 times 9, and this can be get by x times x. Then I can follow that. So I can either do minus and plus also, okay? So first terms, we make sure the first goes first. 9 times 9 gives me 81, and x times x gives me x squared. Get it? K squared plus 25. This is a squared term, this is a squared term. K times k, 5 times 5. But there is no difference in between. That's why we cannot further factor. And now if we follow the GCF method, greatest common factor, do these two terms have anything in common, anything common factor? No. So that's why we will write it as prime. They cannot be further factored, okay? Now this, 9b squared minus 100. 9b, is it a perfect square? What times what makes 9b squared? 3b times 3b. And 10 times 10 makes 100. And it's a minus. It only works with a different sign in between, okay? So we'll write two parentheses. Plus minus 3b times 3b, 10 times 10. So these are the two factors. Easy? Okay. So this one, 16a squared minus 121. 16 is a perfect square. Yes, because it comes by 4a squared. So plus minus, we will do 4a times 4a gives me 16a squared, and 11 times 11 gives me 121. Very good. The next is, again, difference of square. Can we check? This is 2h times 2h gives me 4h squared. 5g times 5g can give me 25g squared, right? So I'm going to write plus and minus first, and then 2h times 2h, 5g times 5g. Good? The next one. Now, whenever there is a difference, the first term is squared, and you have a bonus number 1. 1 is always a perfect square, perfect cube, perfect number raised to the power 4. 1 is always good to have it, okay? So is this a perfect square? Yep, because xy times xy gives you x squared y squared. So I'm going to do xy times xy gives me x squared y squared. When you're multiplying, you add the powers, okay? You're not multiplying the powers. And 1 times 1 gives me 1 squared, which is 1. Okay? Okay. Now let's do this question. 81 4 minus 25. Are these the perfect squares? Oh yeah, because 9 times 9 is 81. And n squared times n squared is n4. We are adding the squares, okay? We are not multiplying them. And 5 times 5. So do the same thing. Plus minus 9n squared. 9n squared gives me 81n4. 5 times 5 gives me 25. Good. Let's move on to the next topic. The next page. Few more examples. Okay, 4 is a perfect square, c is a perfect square, 2c times 2c gives me this. But is 5 a perfect square? No, d square is a perfect square. We cannot apply the difference of squares. They have to be, the whole term has to be a perfect square. Okay, but they ask us to factorize. Can we find the GCF, the greatest common factor, the greatest which can be divided by both? No, so this is a prime. Now this one. K6 is a perfect square. Yep, how? When I multiply K3 with K3, I add the powers. Right? In multiplication, you add the powers. You are not going to look for 3 times 3, 9. For powers, it's different. When you multiply, they're added, okay? So it is a perfect square. And this is also a perfect square. Do they have minus in between, a difference? Oh, yeah. So the two parentheses plus and minus K3 times K3 gives me K to the power of 6, because 3 plus 3 is 6. And then 4 times 4 gives me 16. Be good? Now, 121 or 6 minus 1. 1 is also a great number to deal with. And 121 is a perfect square 11. R6 is a perfect square. Why? Because 3 plus 3 gives you R6. So I can write 2 parentheses plus and minus 11 R3 times 11 R3 gives me 121 R6, and 1 times 1 gives me this. Okay? Now, multi-step factoring. Look for a GCF first, then factor the difference of squares. Okay, so over here they tell you have to do 2 steps. First, look for the GCF, and then you will have a factor where you can apply difference of squares. So let's do that. Okay. 24a squared, 54b squared. Oops, no. Here I can see this is a perfect square, a times a. This is a perfect square, b times b. But 24 and 54 are not perfect squares. What two same numbers multiply gives you 24? None. So first of all, look for the GCF, means greatest common factor which can divide these two coefficients. I know is 6, right? So I factor out 6. Now I have to divide this 24 with 6. I get 4 a square as is minus 9b squared. Okay, 54 divided by 6 is 9. Now I can see this factor, keeping this aside, is also a perfect square again, because 4a squared, 4a, this is a perfect square, and this is also perfect square, and we do have minus sign in between. So I can apply difference of square here. Okay, keeping this as is, I'm copying this as is. I'm gonna factor this further out by making 2 parentheses like what we did here. Okay, so plus minus, I'm just factoring this one. 2a times 2a gives me 4a squared, and 3b times 3b gives me 9b squared. So these are the factors of this, okay? Good. So look for GCF, the common factor. In this one, this is not a perfect square, this is not a perfect square. Okay, look for GCF, the greatest common factor. Okay, so 45 and 20, which is the greatest number which can divide both at once? Is 5, right? And do they have, if you remember yesterday's topic, it's q cube and q, we factored out the smallest variable, exponent variable outside. So I'm going to factor out q here. What do I left? 1. 45 divided by 5 is 9. q3 divided by q gives me q square. When you divide, you subtract the powers. Minus 20 divided by 5 gives me 4. Q divided by q is 1, so I don't have to write actually 1. What do I get? Oops, I got a perfect square. You can see 9q squared. It's a perfect square because 3q times 3q gives this. There's a difference here, and 2 times 2 means I can apply difference of squares here. I'm going to copy this 5q as is. I'm going to make 2 parentheses because this is a difference of squares. I can factor this further. Plus minus 3q plus 2, 3q, 2. Good. 3q times 3q gives you 9q squared. 2 times 2 gives you 4. We good? Okay, now let's do question number 27. 8x squared y, 32y cubed. I have to factor. Whenever you're factoring, look for the greatest common factor first, always. I can see 32 and 8 are divisible by 8, right? 8 is my greatest common factor. X squared, there is no x squared, so x squared is not a common factor. Y and y cubed. Yes, y, the variable with the smallest exponent. If they have the same variable, factor out the smallest variable. So I'm going to factor out this. This is a common factor. So when I divide 8 by 8, I get 1. 1, there is no x squared, so 1x squared. I don't actually have to write 1. Y divided by y is again 1. So I don't have to actually write because 1 times x squared times 1 gives me the same thing. Minus 32 divided by 8 is 4. Y cubed divided by y. When you are factoring out, we divide, okay? It gives me 4y squared. Now you can see a difference. You can see a squared term. You can see a squared term. I'm going to copy this 8y. I'm going to do it here. 2 parentheses. X times, plus and minus. X times x gives me x squared. 2y times 2y gives me 4y squared. Good? Okay. So now let's do 29, 31, and 33. Okay, GCF, because these are not the perfect squares. Yep, I can factor out 3. If I factor out 3, I get n squared minus 49. Okay? Now, is it a perfect square? Difference of squares? Difference, and these two are squares? Yep. So I'm going to copy this, make 2 parentheses, plus, minus. The first one is n times n. This we get 7 times 7. We got? Okay, here. I'm going to factor out GCF, okay? So m cube and m, I'm going to factor out with the smallest variable m, and n. Both are common in this, right? When I divide m3 by m, I get m squared. N divided by m, 1, so it cancels away. Minus mn divided by mn gives me 1. Is this a perfect square? These two are perfect squares, so this is difference of squares. So I'm going to copy this as is, 2 parentheses, m, plus and minus. The first one is m times m, and 1 times 1. Got it? The last one. Okay, so here I'm going to factor out something, GCF. Yep, 80 and 125, they both are divisible by 5. And n squared and n4. So the common would be the variable with the smallest, n squared. Now 80 divided by 5 gives me 16. n4 divided by n squared gives me n squared, minus 125 divided by 5 gives me 25, and n squared divided by n squared is 1, so I don't have to actually multiply 1 with this. Now this is again a difference of squares. This is a squared term, 4n times 4n, and this is a squared term, 5 times 5. So I can copy this n as is, and I'm going to copy 2 parentheses. It will give me 4n times 4n, it will give me 5 times 5. Okay, so today's topic was factorization with GCF and then difference of squares. I hope you understand the concept. Thank you. Assalamu alaikum.